Hello everyone, my name is Sunampiku and I'm a Year 2 student from Chemical Engineering. Today I will be presenting my engineering mathematics project. This project is divided into two parts. The first part focuses on the kinematic and the second part covers uniform circular motion. Now I'm gonna explain part 8 of my engineering mathematics project, which is based on kinematic. The problem is about a student sitting in a car that accelerates away from traffic light during a heavy thunderstorm. This student noticed that the rain streak on the window changed their angle from 45 degrees with the vertical to 60 degrees over a time period of 2 seconds. The car acceleration is given 1.3 meter per second square and we assume the rain is falling vertically at a constant speed. Our task is to estimate the speed of the rain. When the rain falls vertically, but the car is moving forward, the streak we see on the windows are slanted. So the horizontal line of the streak came from the curve velocity, when the vertical line came from the rain or falling speed. Let's call the time when the angle is 45 degrees as T1 and when the angle is 60 degrees as T2. So T2 equal to T1 plus 1 and we move the T1 to the left side and so become T2 minus T1 equal to 2 seconds. That means delta T equal to 2. Using the angle relation from basic trigonometry, tangent theta equal to opposite side by adjacent. So at 45 degrees, the vertical and horizontal speed are equal. This means tangent 45 degrees equal to horizontal speed by vertical speed equal to 1. Tangent 45 equal to speed of the car v1 by speed of the rain equal to 1. So speed of the car equal to speed of the rain. After 2 seconds, the car horizontal velocity increased because of the acceleration. So tangent 60 degrees equal to root 3. So speed of the car v0 x by speed of the rain equal to root 3. So speed of the car equal to root 3 equal into speed of the rain. From the definition of constant acceleration, A equal to final velocity minus initial velocity by time taken. So A equal to v0 x minus vx by 2. v0 x minus vx equal to A delta t, and after we calculate, we get 2.6 meter per second. So we substitute the answer in the equation, what we got in the previous slide. So we get the A equal to root 3 minus 1 speed of the rain by time. So we get the speed of the rain equal to 3.55 meter per second. So the rain falls vertically at about 3.55 meter per second. The only reason the straight angle changes is because the car horizontal speed increases. The vertical speed of the rain never changes. And the second part, we analyze a theme park ride, specifically a Ferris wheel. This Ferris wheel rotates with an angular velocity of 3.14 radians per second and has a radius of 5 meters. Each passenger rotates in a vertical circle while seated in a cubicle that stays horizontal. We consider Mr. X, who has a mass of 100 kilograms. The test for number A is we need to find the time taken for 1 revolution. So it gives the angular speed as 3.14 radians per second and the radius r equal to 5 meter and mass of the Mr. X equal to 100 kilogram. We use g equal to 9.8 meter per second square here and pi equal to 3.14. For the time taken for 1 revolution, the relationship between angular velocity and time taken is t equal to 2 pi by angular velocity. So we get the 2 seconds for time taken for 1 revolution after we calculate. Next, the linear speed. For circular motion, angular velocity equal to velocity by radius. So we need to calculate to get v. So v equal to angular velocity into radius. So v equal to 3.14 into 5, and we get the answer of 15.7 meter per second for linear speed. This is the speed along the tangent to the circle. Often we call that tangential velocity. In uniform circular motion, saying like linear speed and the tangential speed means the same things. So as seen, now the centripetal acceleration, which points toward the center of the circle and keep the passenger moving in the circle. So we use the equation of A equal to angular velocity, square root of the angular velocity into r. So we get the answer of 59.3 meter per second square after we calculate. So the last question of this topic. Number D. In number D, we are asked to find the force which is the duplicate exert on Mr. A when he is at the bottom of the Ferris wheel. At the bottom of the Ferris wheel, two forces as on Mr. X. The first one is weight W. This is the downward force due to the gravitational force, W equal to mg. Another one is normal force, F. This is the upward force from the duplicate on Mr. X. At the bottom, the centripetal acceleration is upward, so the upward force mass equal to ma. So we use the Newton's second law. Net force minus mg equal to ma, so therefore, net force equal to ma plus mg. So after we substitute the number, we get the answer 5909 Newton for the net force. Now we reach the end of our topic that complete the solution already. Thank you for listening to my presentation, and I hope you find it as interesting as I did when working is on. Thank you very much.